Good morning students. I hope you are completing the notes which I send you in the school app as well as that back exercise also, so that your work will not become that panty and you can concentrate in our next class which I am going to explain today. Okay, so learning outcomes of today's class are the concepts of speed, the kinds of speed, velocity, kinds of velocity, mass and weight and the instrument which are used to measure mass and weight, and the explanation of the back exercise. Okay, so specialty of today's class is, in this class most of us will be able to clear our doubts because most of the time we are confused about some terms and we are using these terms wrongly, like speed and velocity and mass and weight. So this class will be will help you to clarify your doubts about these terms. Okay, so let's start. As we have studied in our previous class about the rest and motion and the kinds of motion, now we will proceed to our next topic, or the physical quantity, that is the speed. So before explaining about the speed, I would like to explain about the distance, because the speed is the ratio of distance and time. Time already we know that what is the time, okay, but what is exactly, how can we define the distance? So distance is generally used in our everyday life, but how can we scientifically define the word distance? So the actual length of the path traveled or the covered by a moving body irrespective of its direction is called the distance. That means distance is that length of the path of a moving body from one position or one point to the another point, or we can say in short that is it is the distance or it is the length of the path of the 2 points irrespective of its direction. That means moving body can travel in any direction, it will be called the distance. Okay, that is why the distance cannot be 0 or negative. Distance can be positive only. Okay, so this is the distance, and the unit of the distance in CGS system, that is centimeter, and in SI system it is meter. Okay, so now we will see the speed. So we know that when a body is in motion, the rapidity or the rate of its motion at a particular moment is described by this physical quantity. This is called the speed. So the speed is the rate of change of motion of a moving body, or we can say the speed of a body is the distance traveled by that moving body in per unit time. So by defining speed, we got this formula to find the speed, that is the speed is equal to distance covered by an object upon time in which the distance is covered by the object. Okay, so in that way we can find the we got the formula V is equal to S upon T, where V is the speed of the body, or we can say the speed of the moving body. Clear? S is the distance covered by that moving body, and T is the time in which that distance is covered by this moving body. So this is the formula to find the speed, which is very useful in that numerical purpose. Okay, now the units of speed, actually the standard international system, or we can say the SI system, the unit of speed, we can find this formula of the speed by that formula like V is equal to, that means speed is equal to distance upon time. So the SI unit of distance is meter and the SI unit of time is second. So in that way we can find the unit of speed. So it will be meter per second. In abbreviation form we can write it meter per second, or ms to the power minus where, okay, where m is the meter and s is denoted for the second. So this is the speed which consists by a moving body. Now we will see the kinds of speed. So the speed is categorized in three ways. uniform speed, non-uniform speed and average speed. As we have seen about the motion, we have seen the uniform motion and non-uniform motion. In the same way we will see about the speed also. So first we will see the uniform speed. So uniform speed, when a body is said to be moving with the uniform speed if it covers equal distances in equal intervals of time irrespective of the direction throughout its motion. That means when we will talk about the speed, there is no need to mention the direction, only that magnitude, or we can say the numerical value is needed. So this is called the uniform speed. Suppose a car is traveling in a straight path and it is taking the distance of 30 km from point A to B within 1 hour. Okay, from point B to C, it is taking the next 30 km in the same time interval, that is of 1 hour, so that we can say that the car is moving with the uniform speed because it is taking the same distance in same interval of time. Same distance, that means in every hour it is taking the distance of 30 km. Another examples also we can take, that means the earth revolving around the sun. Okay, actually this is also the example of rotatory or circulatory motion, but here that earth the speed of the earth is uniform because it is taking the equal distance in equal interval of time, as well as it is with the moon also. Okay, so our next example can be the table fan. Okay, this is also the example of circulatory motion, but the blades of that table fan are also in the uniform speed because they are taking the equal distance in equal interval of time. They are not changing their speed. Okay, another example we can take like that second hand of that wall clock. It takes the complete round in 1 minute. Okay, without changing the distance or without changing the times of interval. Okay, so this will be the example of uniform speed. In our everyday life, you can also identify the example which are the examples of uniform speed. Okay. Our next type of speed is the non-uniform speed or variable speed. Variable, that means which can be changed. So when a body is said to be moving with non-uniform speed if it covers unequal distances in equal intervals of time irrespective of the direction throughout its motion. That means when the moving body covers unequal distances or the different distances in the same interval of time, that means distances will be different but the time interval will be same. In any of the direction it is moving, it is said to be moving in the non-uniform speed. Okay, suppose if the car covers 40 km from point A to from point B, 20 km from point B to point C, and next 30 km from point C to point D. In such a situation, it is describing the non-uniform speed because it is taking the different distances in equal intervals of time. Another example also we can take about a participant which is running in a race is the example of non-uniform speed, as he starts with the high speed but eventually slows down. Our next example can be of the speedometer. Speedometer is which is that placed in front of any vehicle which shows the speed of the vehicle. When we travel in a car, we push the accelerator to increase the speed and brake to decrease the speed. That means the speed of a vehicle is not constant, it is changing. That means speedometer also shows that non-uniform speed. Our next example can be of a train coming to a halt or reaches at any station, it decreases its speed. That means when that train is moving in a straight track, it is in the uniform motion, but when it takes a halt or reaches at any station, its speed decreases and it shows the non-uniform speed. So these all are the examples of non-uniform speed. Our next speed is the average speed. So when the body travels with a non-uniform speed, we calculate the instantaneous speed and the average speed of the body to describe its motion. Actually, instantaneous speed is not given in our syllabus, so we will see the average speed only. So when a body travels with a non-uniform speed, then the average speed of the body can be obtained by dividing the total distances traveled by the total time taken. In our that previous example, as we have talked about that car, okay, when it was moving with the non-uniform speed, so total distance covered by that car is 40 kilometer, 20 kilometer and 30 kilometer in every different points. That means the total distance will be 90 kilometer. So and the time is 3 hours. Okay, so in that way we can find the average speed by putting this formula. So the formula of the average speed is total distance covered by that moving body upon total time taken to cover the distance. Okay, so in that way we can find the average speed. We have just learned that speed does not tell any about the direction of motion. The physical quantity which gives both the distance travelled and the direction of motion is called the velocity. That means velocity is the rate of change of motion in a specified direction, or we can say that the distance travelled by a body per unit time in a given direction is called its velocity. So our next term is the velocity. In simplest way we can say that the velocity is the speed only but in a particular direction. That means here along with the magnitude or the numerical value, the direction is also needed. Suppose I am saying that a car is moving with the speed of 30 km per hour. That means speed is given, but when I am saying the car is moving with the speed of 30 km per hour in the direction of east, that means here velocity is given. So this is the main difference between speed and velocity, where in speed direction is not needed, but in velocity along with the numerical value direction is also needed. Okay, so velocity has the same unit as the speed because it is the speed only. So in CGS system as well as in the SI system also, in CGS system the speed, the unit of the velocity is centimeter per second, and in SI system the unit of the velocity is meter per second. Okay, so this is all about the velocity. Now we will see the kinds of velocity. So kinds of velocity, that means velocity is categorized in 3 ways, that is uniform or constant velocity, non-uniform velocity and the average velocity. So first we will see the uniform or the constant velocity. So when a body travels in a straight line, or we can say in a particular direction and covers equal distances in equal intervals of time, it is said to have the uniform velocity. Okay, suppose in this given example, in this given diagram, you can see this truck is traveling at 5 miles in all the position at A, B and C, and all in the intervals of 5 minutes each. That means the truck is taking the equal distance in equal interval of time in a straight line and moving in a particular direction. So in this way we can see that the truck is having that uniform velocity. Okay, actually uniform velocity may have in the body only if it covers equal distance in equal intervals of time. That means the magnitude does not change. Okay, magnitude, that means the numerical value. Okay, and its direction remains the same. If any of the two condition is not fulfilled, then the body will not have or will not be moving with the uniform velocity but with the variable or the non-uniform velocity. So now we will see the variable or the non-uniform velocity. So a body is said to have non-uniform velocity when it covers unequal distances in equal intervals of time in a particular direction. Okay. Or we can say that when a body covers unequal distances in equal intervals of time in a specified direction, or equal distances in equal interval of time but its direction is changed. Okay, that means either the distance can be changed or the direction can be changed. In such a case, we can say that the body is having the variable or non-uniform velocity. You can see in this diagram that one example is given here. Suppose that car is moving with a constant speed in a circular path, and it is moving from point A to from point B, then C, then D. So in such a case, we can say that if when it takes the turn, it will change its direction. Okay, though it is moving with the uniform speed, but when it is taking the turn, its direction is changes. Okay, so in that case, we can say that the car is moving with the variable velocity because it is changing its direction. Clear? So this is all about that non-uniform or the variable velocity. Now we will see the average velocity. So the average velocity, if the velocity of a body in a particular direction changes continuously at a uniform rate, then the arithmetic mean of the initial and the final velocities, that means the velocity or the speed in which a body starts moving. Okay, the final velocity over a given period of time is called the average velocity in that direction. Okay, or in simple language, you can say that the average displacement of a body per unit time when the body is actually moving with the velocity is called the average velocity. Okay, that means suppose we have taken, that means average velocity we can find in that case only when the body is moving with the non-uniform velocity. Okay, so to find the average velocity, we have that formula, that is the total displacement upon total time. Okay, so in that way we can say that that body is the average velocity of that body is this. Okay, it is possible to have a body with average velocity 0 but not with the average speed 0. Okay, so this is all about the kinds of velocity. As I told you in the beginning of this class, that the specialty of this class is that in this class we will able to clarify most of our doubts regarding some of the terms in which we are most of the time we are confused how many times we use them wrongly. So mass and weight are the terms, most of the time we use them wrongly. Okay, so now we will see about the mass and weight and the instruments which are used to measure the mass and weight. So mass is the basic property of matter. Actually, it is the amount of matter contained in a body. It is a constant quantity for a given substance and does not change with the change in the position or location. Actually, it is a constant quantity. That means a body contains the same quantity of matter whether it is on the earth or on the moon or anywhere in the universe. That is, the mass of an object is the same everywhere. It does not change from place to place. That is why it is a constant quantity. Okay, it can never be zero also. Mass can never be zero. Okay, it is represented by the symbol m, and the mass of a body can be measured with the help of two pan balance, or we can say that beam balance or the physical balance. You can see in this diagram, this is the physical balance. Mostly it is used in the lab for the practical purpose. Okay, so I hope that point is clear about that mass. Okay, so it is a fixed quantity and the SI unit of mass is kilogram, and we can find the multiples and the sum multiples of that SI unit of mass. Okay, so now we will see the weight. So weight is the force with which the earth pulls a body towards its center. That means, as we know that the earth attracts everybody or all the objects towards its center with a certain force, and this force of attraction depends on the mass of the body and the acceleration due to gravity, that is g, at that place. Okay, so the weight of a body is the force with which it is attracted towards the center of the earth. It is represented by the symbol W. Okay, the weight of a body is not a constant quantity but depends upon the acceleration due to gravity acting on the body. So the acceleration due to gravity is not same at all the places on the surface of the earth but changes from place to place. Okay, it has been found that acceleration due to gravity is maximum at the poles of the earth and minimum at the equator. So the weight of a body of a given mass shall be maximum at the poles of the earth and least at the equator of the earth. Okay, so this you have to remember. Clear? So the SI unit of weight is Newton. Okay, and the weight is generally measured in the gravitational units such as kilogram force, and it is denoted with kgf or gram force. Okay, and the instrument which is used to measure that weight is called the spring balance. You can see in this diagram. Okay, this is the spring balance which is mostly used to find the weight. Okay, so after explaining about the speed and the velocity and mass and weight, now this is time to solve the back exercise. So our first question of exercise 2.2 fill ups, and the first question is the distance covered by a body in unit time in a specified direction is called the velocity, because as well as along with that numerical value the direction is also specified, so it will be the velocity. Second one is the distance covered by a body in unit time is called the speed only, because the direction is not mentioned, so here it will be speed. Third question is when a body covers equal distances in equal intervals of time, at the blank place you have to write the time in a specified direction, it is said to be moving with the uniform velocity. Okay, now the next one is the weight is found by a spring balance. Okay, spring balance to find the weight. The weight of a body, next one, the weight of a body can be zero but not the mass, because it depends, that weight depends on the place. It is not the constant quantity, mass is the constant quantity. So at the blank place 0 will come. Okay, now the next question, statements given below are incorrect. Write the correct statements. First one, distance covered by a body in unit time in a specified direction is called its speed. No, it will be the velocity, because the direction is mentioned, so at the place of speed you have to write velocity. Okay, next one, when a body covers unequal distances in equal intervals of time, it is said to be moving with the variable velocity. No, here direction is not mentioned, only that distance and the time is mentioned, so we will write the speed at the place of velocity. Okay, our next question is when a body covers equal distances in equal intervals of time in a specified direction, it is said to be moving with the uniform speed. No, here you have to write velocity at the place of speed, because direction is specified. Okay, fourth one, a freely falling stone has non-uniform velocity. How it is? It has the non-uniform velocity because when we throw that stone at the upward direction, it will change its direction. It will come down. That means either the distance or the speed will change, or that direction is changed. So it will be the non-uniform velocity. Fifth one, the milligram is the multiple of kilogram. No, milligram is the sub multiples of kilogram. Okay. Now next question is the true false. First one, when a body starts from rest, its initial velocity is 0. True. Initial velocity, that means the speed from the starting point. If it is at the position of rest, that means it is not moving. So it has the velocity, it has the 0 velocity. So answer will be true. Next question, the sub multiples of kilogram is quintal. No, quintal is the multiple of kilogram. So second answer will be false. Third one, the acceleration due to gravity is 981 centimeter per second square. Actually, the value of the acceleration due to gravity is the constant value, which is 9.8 meter per second square. Okay, but by changing this value in this unit, we will get the answer of 981 centimeter per second square. So the answer will be true. Okay. Fourth one, a horse covering 50 meter in 5 seconds in a straight line has a velocity of 10 meter per second. No, it will be false. Okay. Fifth one, the weight of a body can never be 0. False. Weight of the body is not the constant quantity. It can be changed or it can be 0. So the answer will be false. Okay. Our next question is the choose the correct answer. First one, SI unit of weight is Newton. Okay, so the correct answer will be Newton. Second question, a beam balance is employed to measure mass. Okay, because beam balance is the instrument which is used to measure the mass. Okay, so the correct answer will be mass. Third one, the SI unit of speed or the velocity is meter per second, because speed and the velocity both has the same SI unit, that is meter per second. So the answer will be D, meter second to the power minus 1. Okay. Fourth one, this SI unit of mass is kilogram. So the answer will be B, kilogram. Okay. Fifth one, a body weighs 2 kilogram force at the equator. Its weight at the poles will be more than 2 kgf, because that the weight of the body is highest on the poles and lowest at the equators. Okay, so answer will be B. So in that way we have completed this chapter 2. I hope you understood everything which is taught to you, and so that's all for today's class. Thank you and have a nice day.